academic stars. Welcome to Caltex Academy. Today on our board we have another question that is looking very interesting, and that is on compound angle, saying prove that sine 75 equals root 2 into root 3 plus 1 divided by 4. It means we have to do something to sine 75 in order for us to get the right hand side. So with all this said, let's get started and take a look at the solution. Now, when we're given this kind of question, what we can do is to write this into angles, and by having special angles of 30 degrees and 45. So after adding this together, we have this to be expanded, and we look at that expansion in one of our previous video popping up on the screen here. You can also take a look at that video after finishing watching this. So let's go on and have this expansion. So here we start with sine of the first angle, that is 30 degrees, and we multiply it by cos of the next angle here, and that is 45 degrees, and we add this to the cosine of the next angle, that is 30 degrees, and we multiply this by sine of the angle 45. So we're finished with our expansion. Find the sine of these angles. A sine of 30, and if you don't know how to make them overhead, please go ahead and draw yourself a guiding triangle. So we can go ahead and have this as 1/2, and this 1/2 multiplies 45. So let me put it in a bracket, and the next angle here is cos of 45 is the same as 1 over root 2. So we close up this bracket, that is meaning multiplication. So we add it to the next number here is to be multiplied also. So let's have this in a bracket, and let me finish up this bracket before putting in what we have there. So after that, cos of 30 is the same as root 3 over 2, and we multiply it by sine of 45 is the same as 1 over root 2. So when you press this from a calculator, it will rationalize it for you, and you have something the same as root 2 over 2 is the same thing like 1 over root 2. So let's move on and continue simplifying. Now when you multiply the numerators, we'll have here 1 over multiplying the denominator, we have 2 root 2, and the first term here is done. So we have to add it here to the next term, and that is root 3 over root 2, and this 2 also multiplies that. So we have 2 in front here. Now, since the denominator is the same, we can write in a common denominator. Before I write it down, you can see here that we are having in our right hand side root 3 plus 1. So when we swap this, saying root 3 plus 1 and 1 plus root 3 is the same. So let me start with here root 3, and this is added to 1, and we keep it under the same common denominator, and our common denominator is 2 root 2. Now it's almost looking the same here, except we have root 2 in the numerator, and here we don't have. Since we have here a real number, then we can move on and rationalize this fraction. So let's get space, and from here I will just simply rewrite that. Now multiplying both the numerator and the denominator with the same denominator here, that is 2 root 2. Okay, let's have a division sign. We divide this by also 2 root 2. Now we can move on and input what we have here earlier on, that is root 3 plus 1. And in the denominator, we also have 2 root 2. So I've just simply multiplied both the numerator and denominator with the same denominator in order for us to rationalize that. We can see here that these 2 will cancel with the other 2. Now let's maintain the numerator because it's looking the same like what we have up there, and we have here root 2 is multiplying root 3 plus 1, and here we divide this by the denominator, and from the denominator you can see 2 times 1 here, because this 2 has cancelled to 1 will be 2. Then when you look at this, root 2 times root 2 is the same as also 2, and somebody will wonder how. Now when you have root 2 times root 2, we can combine this the same as 2 times 2, and we know 2 times 2 is 4, and the square root, and we know the square root of 4 is 2. So simply, if you have a number under a denominator and multiply by the same number and the same denominator, simply take that number, and that is the rule for you to work this easily. Now let's move on and simplify the denominator, and we are done with our work. Therefore, popping up the numerator again, we have root 2 into root 3 plus 1, and we divide this by a common denominator, that is 4. And this is equivalent to the right hand side, hence shown. Since we are asked to show that this left hand side when simplified will be exactly like the right hand side, and that is it for this question. See you in the next one. Peace out.